Welcome to Utisam Mathematics. I am on the series Functions. In my previous video, I did something on domain. In this video, I'm going to look at the range of a function. The range of a function y is equal to f of x defined on the set of real numbers are all possible values of y, which makes x defined. We have already considered the basis. We said that if you have two sets, set x and set y, all the elements in the first set are called domain. Then all the elements in the second set are codomain. But all the elements in this set that has connection with the first set are called the range. So how do we find the range? They are the set of values of y that makes the domain defined. Okay, note, to find the range, we make x the subject of the equation of the relation. We then find out whether there is a value of y that will not make x defined. Now all the categories of finding the domain work here. So let's take some examples. Find the range of the following function defined on the set R of real numbers. Our first function is f of x is equal to 9x minus 13. So we said that to find the range, we let y be equal to the function f of x. So this implies that y is equal to 9x minus 13. So we then make x the subject. So how do we make the subject? X the subject. We send 13 to this side. So y plus 13 is equal to 9x. We then divide both sides by 9. So we have our x to be x is equal to 1 over 9 bracket to pin y plus 13. So how do you find the range? We said that all the values of y that will make x defined. This is a polynomial, and for range of polynomial, all the real values satisfy this. Range will be y such that y is a real number. So all real numbers, when you put them here, the function will be defined. So let's look at the second one. So so let y be equal to 3x plus 7 over x minus 5. So we cross multiply. Our motive is to make x the subject. So we have yx minus 5y is equal to 3x plus 7. Since we want to make x the subject, let's group the like terms. So yx minus 3x, which is equal to 7. When you send this one to this side, it becomes plus 5y. So factorize x out. Y minus 3, which is equal to 7 plus 5y. We divide both sides by y minus 3. Y minus 3. This will cancel that. So we have x to be 7 plus 5y over y minus 3. So the range will be in terms of y. The range is, so this is a rational function. So what makes rational function undefined? When the denominator is equal to 0. So y minus 3 is equal to 0, which implies that y is equal to 3. So when y is 3, the denominator will be 0 and the function will not exist. So we take 3 out. So range will be y such that y is a real number except y is equal to 3, or y is such that y is a real number, then y should not be equal to 3. So either way is accepted. Let's move on to the next one. Before I take you through this, I want you to pause the video and then do it. After that, you compare it with your answer. So as usual, let's look at how we go through this. Let y be equal to 1 plus x on 1 minus x. We then cross multiply, yes. So we have y times 1 minus x is equal to 1 plus x. We then expand y minus yx, which is equal to 1 plus x. We want to make x the subject, so you can bring 1 here and then send the term in x on the right hand side. So y minus 1 is equal to x plus yx. We then make x the subject, so x into bracket 1 plus y. So let's divide both sides by 1 plus y, 1 plus y. So this will cancel that. Our x becomes y minus 1, y plus y. And once again, we have a rational function. Now for a rational function not to exist, the denominator must be equal to 0. If that is the case, so 1 plus y is equal to 0, which means that y will be equal to minus 1. So how do we write the range? So range will be y such that y is a real number except y is equal to minus 1. Yes. Or y is such that y is a real number, then y should not be equal to minus 1. So any one is correct. Let's look at the last one. Once again, pause the video and try to solve this. So y is equal to g of x. That. So y will be equal to x squared plus 1. So we want to make x the subject, which implies that x squared plus 1 is equal to y. So x squared will be send 1 to the other side, y minus 1. So x will be, take the square root on both sides, square root here minus 1. So to find the range, now there is a function under the square root sign. When do we have, or when a function is under a square root, what makes it undefined? That is when the function is strictly less than 0. That when you evaluate the function and the value is negative, then the function will not exist. At this level, remember, so y minus 1 is less than 0, so y is less than 1. So the range becomes y such that y is a real number except y is less than 1, or y is such that y is a real number, y is greater or equal to 1. I've explained this in my last video. That when it is literally less than, it means that all the values greater or equal to will be satisfied. Let's look at the last one. F of t is equal to square root of t minus 1. Now we let y is equal to f of t. This time the function is in terms of t, which means the independent variable is t. So this implies that y is equal to square root of t minus 1. And we are not making x but we are making t the subject rather. So how do we make t the subject? The t is under a square root sign. So to make t the subject, we get rid of the square root. So let's square both sides to take care of the square root. So which implies that y squared is equal to t minus 1. So this implies that t will be equal to y squared plus 1. We send this one to this side. And this becomes a polynomial. In range of a polynomial, all the values satisfy the function. So range will be equal to y such that y is a real number. So all the real numbers will satisfy this because it is a polynomial. Viewers, I know you are blessed with this video. In case you have not subscribed, kindly click on the subscribe button. And then you turn on your notification button so that anytime I drop a video, you'll be alerted. You can also leave your comment. You can also share with your friends.